So let's
Thank
get
you.
started with this lab because we are going straight in to the memory analysis lab. Now, this is going to be one of those rare times. I'm going to have you guys run the first few commands with me. So let's make sure your VMs are started and running, and you're going to open up a Kali terminal, right? I'm actually going to take my Kali terminal. I'm going to change my settings. This is trying to buy time. I need you guys to follow along because there's a command that takes a while to run at the beginning of this particular lab. So once again, the whole goal of memory analysis and the reason why memory analysis is so incredibly powerful for us is because it allows us to do threat hunting on systems that are dead. Like, sorry, let me rephrase that. The memory analysis is not live, right? You're doing the snapshot of the memory in time, and the system's running and doing its own thing. And it's like, what is it? The Riker paradox in Star Trek. I don't know if you guys remember, there was an episode in Star Trek where Riker comes across another version of himself. Apparently, there was a transporter incident, and there were two separate Rikers, and they both lived their whole lives. And one was, Starfleet, and the other one, I don't know, became a criminal. I don't know. Maybe he sat in chairs normally. I'm not exactly sure. It was the late 80s and 90s, so I don't remember a lot of it, but there were two of them. And that's what we do with memory. We split this memory, and then it allows us to do analysis of that memory in a way that the attacker would never be able to detect it. So I've got my Kali prompt open. I'm going to become root here. Become root. And then we're going to cd into the opt volatility directory. There we go. And then we're going to run this command. Now, if you all could just run this command just to start, I would appreciate it while I'm walking through because it takes a long time. And I'm going to explain why it takes a long time for volatility to fire and work properly in this. Okay, so apparently it's going a lot faster this time. But at any rate, whenever volatility is running, it's reaching out to the internet and it's grabbing a database from Microsoft for symbols that basically is where in memory do certain things exist, like open files, open network connections, things of that nature. And then it pulls that back down for the specific version of Windows that matches the memory dump that we're analyzing. And this is like a Windows 10 memory dump that we're actually looking at in this particular one as well. So you're going to run that, and then it's going to tell you that there's this process called trustme.exe that's a little sketch, just a little bit sketch there. And I'm going to talk about when we do the full walkthrough why it's a little bit sketch, but we'll get more into that here in just a little bit. Then we're going to do net scan. This is going to go through and look at all of the network connections. In this particular system, you're going to see that we have a connection to a suspicious port from trustme.exe, but we also have a network connection to another internal system on port 445. Then you're going to run PS list to get a process listing from this system. And then you're going to do PS tree to see the process hierarchy. Not bad. Then we're going to do the DLLs to look at the installed dynamic link libraries into that trustme.exe process. Now, this particular lab is going to take us probably 20 minutes. So we're going to set 20 minutes on the clock. And the biggest reason why it's going to take 20 minutes is because it can take a while to reach out to the internet and grab that information from Microsoft, pull that data down, and then start parsing through all of the different parts of the memory. And the reason for that, once again, is because different versions of Microsoft have different locations. So Windows Server, Windows 10, Windows 10 SP, whatever, or Windows 11, Windows 10 in Arabic and Russian have different memory address locations for key assets like network connections, open files, and open processes. So it takes a little while for that to fire. So mine just came back. I'm going to run the second one just to get it running for me. So whenever I do the walkthrough, it starts running a little bit faster. And then we're going to start the clock. All right, so let's set that 20-minute timer and we will come back and then I will do the walkthrough. Let's get rolling. All right, and we are back again. All right, so let's go through each of these and talk about why this is important. and what volatility is actually looking at and looking for. So this first one is kind of interesting. I kind of restructured the lab. I used to have this one as the last command that I would have the students run just because I was like years ago, it was like, oh, that's kind of cute. We'll throw that in. And it got better and better as time went on, and it's pretty solid, right? Mm. Got some coffee, decaffeinated, of course, decaffeinated, not instant. But it's I think today I'm running on Dunkin' Donuts decaffeinated coffee, so it's pretty good. So this got better over time at detecting malware. Not 100% certainty as far as detecting malware, but pretty solid. So you can see that this particular one at the top, it says that trustme.exe with a process ID of 5452. And once again, I'm going to open up Notepad and I'm going to copy this whole line right here. So I'll take this line, copy it, and then I'm going to put it into Notepad because we're going to come back. We're going to investigate that a little bit more. There we go. Awesome. So we got that. Very cool. So that particular memory area is set to read, write, execute. And that's what got it kind of like freaked out as far as volatility and what it was doing. So trustme.exe is running that. And why is that a problem? Well, if you're looking at memory, memory is usually readable, it's writable, or it's executable. It's very rare for areas in memory to be read, write, and execute all at the exact same time. And that is ultimately what triggered this. Now, in this particular instance, one of the things you'll notice fairly quickly is that wasn't the only one. There was another one. We had trustme.exe, and then Search UI had the exact same type of issue when I was looking at it. So it's one of those things that, like, yes, this can be a good indicator. This can be a good start for trying to hunt down some malware, but it's not 100% accurate every single time when you're working with it. So question, is there a Windows equivalent for PS Tree? If you go back to the Windows lab, I can jump back to that a little bit later. If you go back to the Windows lab, you can do WMIC and you can see the process where you can see the parent process ID. And that would be the closest thing that you would do with that. And then there's a bunch of third-party utilities as well. One of my favorite third-party utilities for that is what is it? Process Hacker. There's a really cool tool called Process Hacker. That's really cool. All right, so that is the first quick smoke check, right? What about this is going to make us start investigating this trustme.exe process a little bit more as far as this investigation goes. So now we have trustme.exe as something that is of interest. Well, let's take a look at what's going on with the network connections. Now, I had mentioned multiple times in this class that there's specific network connections you're going to be looking for, right? We're not necessarily going to be super interested in listening. We're going to be really interested in established, SYN sent, and closed. And right here, we can see that we have two of them right next to each other that are super duper interesting to us. And I went too far. There we go. That's much better. So the first one that we have is the system process. The system process is making a connection on port 445. I'll talk about this more a little bit later, but if you look closely, it's making a remote connection to a different computer. So we have our compromised computer at 192.168.192.145 has made a connection to 192.168.192.146. So we have an established connection between a system that is being investigated that has some very suspicious, weird things going on with it and another computer system on the environment. So that's going to become really important here in just a little bit. But the main thing I want you to take from this is we have that established connection to another system in the environment, and the system process, process ID 4, is the one that made that connection. So I'm going to clarify exactly what this means a little bit later once we start looking at the PS tree and the data that we get from PS tree. But we have our connection, the trustme.exe. If you go through it, did anybody notice that there were multiple instances of trustme.exe? We had established and sent, we had closed. Actually, you saw a lot of repeating values again and again and again. I don't know if anyone saw that in here. That's an artifact of this being memory, right? If you look at memory, one of the key characteristics of memory on Linux and Windows, especially for Windows computer systems, is it is very volatile. So you'll have areas of memory where this information is being stored, and then that area will be marked as it can be writable, but the original data will still be present. And when you're looking at Windows, Windows is just really messy in its memory management whenever you're tracking this information. So that's why you'll see these things again and again and again and again in the same memory dump multiple times. So if we scroll down, we have listening, listening. Let's just focus on those established connections and see if it shows up again. There's trustme.exe again. Once again, that's an artifact of the fact that this is Windows and its memory is very, very, very messy. There we go. We've got listening, closed to the web server. We should almost be done. There it is. All right. So the next one that we're going to do is we're going to look at PS list. What are the processes that are running? Now, this particular one, oh, it's System Informer. Cool. It's got a new name. Thank you very much, Jelly Beanster. So with this, we now can look at the processes and we can see the process ID and the parent process ID. Very similar to PS tree. We'll run that here in just a little bit, but we're going to see a cluster of processes a little bit later on down that are associated with our trustme.exe process on our computer system. There's Chrome. That's how we got compromised in the first place, right? And then we get into TrustMe, and then we get into a bunch of really weird stuff. All right. So we've got Trust Me with our process of 5452. And it also was started with a process, the parent process ID is 3616. Pretty sure that that's Explorer. And just so you know, Explorer doesn't mean like Windows Explorer, your Edge or your browser. It's actually Explorer. That's your GUI for your Windows system. Anytime you click an executable as a user, it's going to have the parent process ID as Explorer. So that's very, very common, chat. It's very, very common. We see that all the time. But then we can see that this 5452 spawned a command executable. All right. So if we're looking at trustme.exe, trustme.exe is making a connection out to the internet. It is invoking a command prompt, right? And then that command prompt opens the connection host and it opens the net command. Now, what's really, really interesting about those command prompts and the connection hosts and the net command is what process made the connection on port 445? Does anybody remember? Up above, we had 445. What actually made that connection on port 445? I don't know if anybody's takers on that. Anyone? Nope, wasn't Metasploit. Although that is kind of right. Metasploit did. Yeah, there you go. Process ID 4. It is the system process. So this is where Windows land gets really weird. And this is where playing around with the stuff in a lab super duper helps. All right. Whenever you run from the a command prompt, and you run the command net use a remote IP address and you connect to that remote system, you're going to run the net command. But here's what's weird. That connection is not made by you who ran the command. What happens is that particular command is invoked by the system process, and the system process makes that connection on your behalf. And this is something that's really common in Windows. If you go into, let's say, group policy. So if you go into group policy or if you go into local security policy, you aren't the one changing the security policy. The system process is changing the security policy. It's just showing you invoking privileged use. So you have a user that was compromised with trustme.exe. Then trustme.exe was spinning off the cmd.exe, ran the net command, which invoked conhost running as system to make the remote connection on the behalf of the user. So this stuff matters because if you ever are testifying in court, you've got to know your evidence inside out and backwards. So how do you know who invoked system to do the thing you asked? For me, a lot of that goes back to experience, right? Let's talk about this in terms of like court, Roswell. So for me, the experience is I see the system process and I know that the system process is invoked by the net command, right? That's just from my experience. If I was going to testify in court, I would demonstrate that's normal Windows behavior. So I would have a test system and I would recreate my theory and I would show how the evidence for my theory matches the evidence for the case to clearly articulate to the judge and jury that I'm not just guessing, that I actually recreated this situation and it matches the evidence at hand. Does that make sense? It just helps. Yep. All right, so let's go ahead and let's keep going. I did not want that. The next one would be the PS list that we wanted to look at. So we can see the process hierarchy. And this really cleans it up for you to be able to see it, even though I use PS. Sorry, um, I didn't want that. I wanted PS tree. Let's go back to PS tree. I use PS list more exclusively than PS tree. I don't. PS tree is cool. It's just I'm used to looking at the output of PS list. All right, so there we go. So now if we look at PS tree, once we get up to our cmd.exe right here, where you can see trust me, then we have the stars of the children underneath it. So we can see trustme.exe begat cmd.exe, which begat conhost and net.exe. So it makes it a lot easier for us to see that data. And then the final one, that DLL list, which is the same thing as task list space forward slash M space forward slash FI. So we're putting in a filter. Space, double quote, PID EQ, in this situation 5452, and it's going to dump out all the dynamic link libraries of interest to us. And we can see those Windows on Windows dynamic link libraries show up again for trustme.exe. All right. So there you go. Pretty cool lab. Now, once again, this is something that you can put on your resume, right? This is absolutely something that you can put on your resume and be like, hey, I've used volatility. I'm convinced, no, I'm comfortable utilizing volatility in an IR type engagement. All right, that brings us to egress traffic analysis. All right, so for egress traffic analysis, this is one of those areas that I'm talking about tomorrow when I'm in Salt Lake City, where when we're looking at active countermeasures, just kind of giving you guys a heads up, with active countermeasures in AC Hunter, it is a tool that is not a completely passive tool. And we have a lot of customers and potential customers like, we just want a tool that's going to be bright, shiny red lights and let us know that we've been hacked and then we can deal with it. Or better yet, it would automatically stop any attacks that it sees. And that's not really what AC Hunter does really well. What AC Hunter shines at is giving you the tools to be able to detect malicious backdoor traffic and beaconing traffic. And like two of the biggest wins that we've ever had that we probably didn't document as well as we could have is number one, I am pretty sure, not pretty sure, we caught SolarWinds before it was actually in the public. So a number of months before it was the Mandiant report and all that stuff, we had a customer in Germany that was doing a proof of concept and they were one of our resellers. It was Sekion is a reseller in Germany. They're awesome. They're now called Algiers, and they do all of our stuff. And they were doing a proof of concept. They were running a network threat hunt, and they discovered that their SolarWinds server was compromised, and it was beaconing. So that particular customer absolutely signed on to that contract. They were really super excited about it, and they weren't excited about getting compromised. But no one in that entire incident looked at it like this is a systematic nation state level attack across the board. Then, when we're looking at the Salt Typhoon, when Salt Typhoon hit, one of those telco vendors that was compromised was one of our customers, and their license had expired. And they detected the backdoor that the Chinese had put in with our tool. So we were at Wild West Hacking Fest, and we got these panicked phone calls from the point of contact, but we need to re-establish our contract with you guys as quickly as possible because we just detected this backdoor. And it turns out it was Chinese nation state level adversary stuff. So when we're doing this, I'm not saying this just to sell a product because we have a commercial version associated with it that you guys can play with, a community version that you all can play with so people can run it in their own homes. They can run it in their place of business. Pretty easy for smaller organizations. But that's how much we believe in this, right? We make this publicly available. So much so when I was at, oh my God, what was the name of that conference? Hold on a second. There we go. Thank you. So yeah, the name of the conference was SciCon. So we're in Tallinn, Estonia, where the NATO Cyber Command is, and we had people from Google come up to us, and they're like, "Hey, we just want to say thanks. This tool is amazing. AC Hunter and all of these things. It's just absolutely fantastic. We've stolen a ton of things from it and put it in our network threat hunting tool." It's like, thanks, Google. All right. So this egress traffic analysis is really important to us, and it's really important to me. So what we want to do is get you in some experience utilizing our network threat hunting tool and talking about some of the back doors that you can encounter when you're doing network threat hunting, which we are going to be doing here in just a second. So I'm going to destroy my lab. There we go. And then we are going to go to the lab directory. I don't even think they thought of it as like a confession. They were just like, yeah, super cool. So we're going to be doing the Rita and AC Hunter lab. We're not going to do Rita 2 yet. I can give that to you as some extra stuff a little bit later, but we're going to be doing Rita and AC Hunter. So you're going to be going to training.aihosted.com. And when you go there, you're going to get this little warning. It's going to say your connection is not private. You're going to log in with these credentials, training at blackhillsinfosec.com, and the password is got beacons. We're all sharing the same system. And then we have a number of data sets that are loaded up into this version of AC Hunter. And you're going to start, you can look at VS Agent and you can load them. And then you can kind of walk through this and get to the dashboard, load the data sets, look at the beacon scores. And then across the bottom, we have a bunch of different tabs, right? We have beacons, beacon fully qualified domain names. We have strobes, long connections, threat intel, DNS, cyber deception, and so on. So just on this alone, I'm going to have you guys answer some questions. Load the WinLab agent dataset, and what is the connection interval for 10.10.98.30? In the GCAT dataset, what is the historic qualified domain name for the beacon 10.55.100.111? For the DNS Cat 2 JAW 3 strobe dataset, what domain has the highest lookup count? And then who is doing those lookups? So you're going to use this and you're going to answer these questions. Now, this is going to take us up to and through the break. Okay. So this is going to be, we're going to resume at quarter after. So I would like whoever's doing the clock, let's go ahead and set 25 minutes on the clock. So we have about, I don't know, 15 or more than that. We're doing pretty good. So we have 20 minutes for the lab and we have 20 minutes for the, or 10 minutes for the break. So go ahead and set it to, let's just set it for 30 minutes and we'll start at quarter after, a little bit of quarter after. And let's get rolling because this is a little bit of a challenge, right? I want you guys to work together. Some of you may be a little bit confused. Some of you have experience with this. Some of you, it's going to be intuitive, but I want you guys to work together as a team in Discord to answer these questions. All right, so let's get rolling. Back, right? And I am sharing my screen. We should be good to go. I just restarted my VM, which is kind of one of those panicky things. I go and I get a cup of coffee and I come back and it's like, crap, I destroyed my VM. Oh, but luckily for this one, what I did forget is you actually don't need the VM for this one at all. All right, so let's go ahead and let's get started. So we're going to go into training.aihosted.com. Get that VM. Got privacy error, self-signed certificate. That's fine. We don't care. YOLO sec. Woo! All right. We're going to do training at Black Hills Infosec. The password is got beacons. Not bacon, but bacon is yummy. All right. So we're going to log in. All right, let's just go right to the questions. The first one was in the WinLab agent dataset, what is the connection interval for 10.10.98.30? Excellent. So I can go to the dashboard and then I can throw this over there so you can't see it. Then we're going to click that and I'm going to choose WinLab agent, confirm. And then I'm just going to go right to beacons, right? And we see that we have a whole bunch of data about this. And one of the things that I really like about this particular lab, um, is I just kind of drop you into it. I'm like, answer these questions. I want you to imagine that you're doing a network threat hunt without something like AC Hunter, right? Like, how much effort would it be to try to answer these questions if you didn't have this tool? Answer is lots. It would be lots. But if we look at the UI right here, we can see that the main mode for the interval is 3,729 connections at 15-second intervals. So a number of you got the 15-second interval thing. So give yourselves a round of applause. Well done, well done, well done. But I want you to look at some of the other things that we have on this screen, right? We have the interval. If you click the 2, it shows the data size. So we have 7,000 connections with 0-byte payloads, which is pretty crazy, right? And then you can see at the bottom, we have a histogram, and the histogram shows the number of connections per hour, and we can change that to every 15 minutes, every 30 seconds, hourly, whatever. We can change all of that up and kind of run with it. So it makes it easy for us to get into this data to understand what's going on. So that one's a pretty easy question to answer. Next question, in the GCAT dataset, what is the fully qualified domain name for 111? Let's go ahead and let's open up that GCAT dataset. There we go. Confirm. Go to beacons. Now you could have gotten this in a couple of different ways, right? Like you could have come here and found it, and you can actually make this font bigger. If it's not big enough, you can just go ahead and increase the font in your browser, right? But you can see that fully qualified domain name is gmail.smtp.msa.google.com. The other way that you could have done it is come over to Beacon's fully qualified domain name, and it shows up right there as well. So there's 2 separate places where you can see that fully qualified domain name. Now, let's spend a couple of seconds and let's talk about nation states. Let's talk about GCAT and why we created it and why it is the way that it is. So GCAT was initially created by Black Hills Information Security. I had a hunch that all of the major firewall, IDS, and IPS vendors, they were completely ignoring any and all things that went to Google. And I had an intern create up a tool called GCAT. He did a fantastic job. And he created this tool that all of the command and control is well-formed email messages. So it checks its email. If there's a command, it executes the command, and then it emails itself the results of that command. And that's how that backdoor works. Now, I mentioned this particular backdoor is used by nation states. This proof of concept that we released was eventually picked up by Russia, and it was used as a precursor to the Ukrainian war when they brought down the power grid in Kyiv. So yeah, we've actually seen this in the wild as a nation state level adversary. And it's just one of the 3 times I've had the FBI contact me and basically say, hey, we need to have a talk. And by the way, it's never confrontational or adversarial with the FBI. They hold my clearances. I have good relationships with them, and life is good. All right. So now let's go to the DNSCAT2 JA3 dataset. This one's actually changed a little bit. I'm going to explain how this is a bit different. So we do DNSCAT2 JA3, and we can go right to the DNS one, and we can answer these questions. And once again, I can zoom in. Well, I can't zoom in for you guys because Zoom doesn't zoom. I'm going to zoom in, and you can see that the domain that has the most lookups is actually r-1x.com. It has 109,227. Okay, that might be okay, I guess, for that domain, even though it's not Google or Microsoft or Pornhub or anything that your users would be going to quite a bit. But hey, it might be legit. And it says the number of fully qualified domain names is 62,468. That's a lot. So what is a fully qualified domain? So Google is a domain. All right. So if I just go to Google, that's a domain. If I go to www.google.com, that's a fully qualified domain. If I go to mail.google.com, that's a fully qualified domain name. If I go to maps.google.com, that's a fully qualified domain name. Now, just so you all know, that's not normal. I don't know of any domain that has 62,468 valid, fully qualified domain names. Even like Akamai and some of those things. That's insane for the number of fully qualified domain names. So that right there is what a DNS backdoor looks like. Next thing it asks is who's making all the queries. And it says, well, all the queries are coming from this one host. And that may be normal. That may be normal. And the reason why that may be normal is because in many environments, the domain controller is the recursive DNS server for the internal systems. So how do we check if that's true? Well, we see how many of these systems or how many of these lookups are from multiple systems, and it's the same system. So the same system that's doing the query is also the system that's making the connections. So this is a DNS backdoor. Name of the tool is DNS Cat 2 by Ron Bowes. I told you this one's a little bit different. I said it's the JAW3 dataset. JAW3 is broken. JAW3 is broken because a bunch of a bunch of browser clients randomize the TLS hello message. So JAW3 is broke and it's being replaced by JAW4 instead. So once again, I want you to look at this from the perspective of imagine you have to do this network threat hunting on your own. I just give you a packet capture, a command line, and a dream. Would you be able to find all of these different things? Would you be able to find the beaconing? Let's say it's a very large data set. It turns out it's hard. Our largest AC Hunter customer is Intel, and they're running 100 gigabits per second through it. We have another university that is running 50 gigabits per second. They're a very large university, and it's insane. So it's not a matter of just can you do this on a small packet capture? It's can you do it at very, very fast, large enterprise environments. And that just kind of shows if you're ever working with somebody and they're like, yeah, we're going to teach you a Python script to do network threading and packet captures, feel free to ignore anything that instructor tells you from that point on, because you cannot use Python for network threat hunting. It just doesn't work. It's not multi-threaded and it doesn't roll. All right, so there we go. All right, so user entity behavioral analytics, UEBA. Let's jump in. So logs are a bit of a train wreck. They're kind of a problem. There's a lot of them, number one. But the other thing is, if you're looking at Windows, there's really not a lot of value in Windows logs. Let me show you real quick. Actually, I want to know what ChatGPT says about this. Let's go to Event Viewer. And if we look at standard event logs, right? If we look at standard event logs, going to take a sec to load. If we go to Windows logs, let's just go to security. These logs are just bad. Like they just really don't give you a lot of security information. Nowhere near as good as you would get from, like, let's say a Sysmon, just as an example, right? So we're waiting for the logs to load. I guess we have 30,000 events. That takes a little while for it to get in and show up. What about system event logs? Oh, let's go to application event logs. That one's always cute, right? If we go to application event logs, so successfully started the software protection service. Reason, rules engine. I want to throw this into ChatGPT. I want to be like, what does this log mean? Because I see it show up in all my classes. Let's go to ChatGPT and see what it says, right? By the way, working on more animation for my talk. I try to get ChatGPT to kind of get the magician to hide the flipper zero. He's not hiding it the way I want him to. All right. So there we go. Wait for it. Wait for it. Come on, ChatGPT. I would laugh if ChatGPT is like, dude, I have no idea. This is. I think it's going to give us something. I'm not going to necessarily trust it, but I think it's going to give us something. Oh my God, it's the Windows Performance Recorder. It's a diagnostic event tracing for ETW, which makes sense. Managing data service token. I'm going to be honest with you. I think I know less about that event log now than I did before. Ugh. I'm telling you, this isn't helping me understand this. I feel like I would have to spend an hour in ChatGPT to figure that out. Like, what is this log doing? All right, but that's fine. Yeah, huh? So they're a train wreck. That's my point. And a lot of organizations are feeding terabytes of this garbage into their SIM, right? Just constantly. And really, if you're looking at traditionally a number of organizations, they say that less than 5% of their detects are from their logs, right? They're getting a lot maybe from their EDR, maybe extrusion detection through their firewall. But as far as like full on log analysis and what's going on, Less than 5%. And honestly, if you ask the question logs and percentages, what percentage of your logs have a rule, alert, or an detect associated with it? Most organizations, it's less than 10%. So we're logging like 90% of this garbage, right? Like, is this something that's going to be useful in an actual incident? Probably not. But we still log it. And one of the reasons is you have a number of vendors that they're the ones that are telling you what you should be logging, and their answer is always more. It's like that question from Wall Street too. What is your number where you give up and you walk away? And the guy's like, more, right? So that just sucks. So you have a number of different organizations over the years that really, really tried to start understanding more of a holistic perspective, what actually is happening on a system. And one of the first groups that did this that needs a lot of credit for it is JPCert out of Japan. So they went through and they ran a bunch of these built-in Windows utilities, WMIC, scheduled tasks, WinRM, to see what would be the impact and the event logs and the registry keys and the prefetch files that would be generated from those services that were being run. And that was awesome. That was a great way to go. Now, this allows you to start feeding into user entity behavioral analytics, because to be able to tell what is going on insofar as an attack is it usually requires us to look at multiple different logs. And this gets very, very, very tight back to what we did with Deep Blue CLI. We're kind of going to refresh that with Enterprise Log Review here in a second. But it can require multiple logs to tell the story, right? There's no single event log that's like, you've been hacked. If we're looking at the password spraying log, that password spraying log required us looking at multiple event logs to be able to tell the story of that attack. If we're looking at some of the other logs, like even I would say the obfuscation logs, yes, there was obfuscation, but the fact that there was multiple obfuscation attempts tells me something very important about it as well. Also, we're looking for things like lateral movement. When we're getting the event logs and we're starting to do that analysis on the event logs, you can see here the SVC white noise account in the upper left-hand corner was attempting to log into multiple other servers. And you can see them by the diamonds that it's trying to log in. It's kind of hard to see, but the point is, there's no one event log that tells that story. Graphically, and this is from JPCert, if you see it graphically, it makes sense, right? It makes perfect sense what's actually going on. But if you're trying to look at each individual event log to try to tell the narrative and tell the story, you're not going to get that narrative. You're not going to get that story from a single event log. So let's go ahead and let's do this. So whenever we're talking about log analysis, we I don't know, we still call them false positives, but at BHIS, I'm constantly fighting the notion that there are things like false positives. Like, it's very, very rare for a SIM or an event log service to just have a completely broken detect, So what we try to do is look at it like these are detection tuning opportunities, right? There's a certain detect, and that detect is usually written by a vendor in such a way to be as milquetoast and bland as humanly possible, because they don't want to trigger in all of the different precious snowflake environments that are out there. So it's really, really just super general, right? Just super general. And that means that you're going to get some quote unquote false positives. People like to call them false positives. Like, if we go back this slide right here, this particular event in your UEBA, in your SIM, in your AI sim, whatever, it should generate an alert, right? It absolutely should, because you have one account that is logging into a whole bunch of computer systems in a very short period of time. But it may not be malicious, right? There might be a legitimate service in your organization that is doing this, and that's part of its job, and it's providing value to your security team. So the answer to this isn't, well, let's disable the log or the alert. Let's disable the rule. It's broken. Just shut it off. The solution to this is to tune it and create an exception. So we would basically go through and say, well, yes, this is an alert. We want to be able to detect it after a threshold, but we're going to create an exception from the SVC white noise system white noise account logging in from this specific system that is running the SVC white noise service, right? So you would do detection tuning on that. because you're going to see this show up with things like service desk, help desk, like systems administrators, scripts, backups, and this tuning is part of our jobs as SOC analysts when we're working on this. So let's give you a couple of examples on how user entity behavioral analytics actually works, right? Like one of the examples of how it works is stacking. And what that means is, let's say that a user logs into a system, right? They're going to get a +1. If somebody logs off of a system, then they're going to get a -1. And then what you would do is you would take a threshold, let's say like 6, right? And then if somebody exceeds that threshold, an alert would be generated. Now, once again, if we go back to like help desk, systems administrator, scripts, and backups, you're going to blow through that, but you're going to create a tuned rule to allow for those types of scenarios to happen. And it's going to be okay. But now, if all of a sudden Bob logs into the system and then the Bob account gets compromised and it's now logging into 2,000 systems, that would be something that you would absolutely want that alert to fire. AI is huge in working with SIMs and things like that. Like we're using Tines as our kind of our SOAR, and we're doing a whole bunch of work with Tines. Ethan Robish, one of our data scientists, is working on it, and he's doing scary AI stuff. Even though it's kind of funny, Ethan's doing amazing stuff, and people are like, "That's really crazy what you did." And he's like, "I don't get it. It's not that hard. It's just math," which I think is probably one of the funniest responses when someone's like, "That's amazing." And you're like, "It's just math." And then again, at the end of the day, isn't it all just mathematics? All right. So AI learns what's normal. It learns what the patterns are for each user. So if Bob logs into 3 or 4 systems a day, that could be normal for Bob. Now, if Bob's logging into 40, that's weird. Now, if a systems administrator is logging into, let's say, 19 systems a day, well, that would be normal for that user. So instead of actually setting like defined set clipping thresholds, AI would learn and baseline what is normal for each of the user accounts. You may have a user that's normally pulling 3 meg off a server a day. And now all of a sudden they pull an Edward Snowden, and then there's bang, 3 gigs, from the Spice Weasel coming off of that system. That would be abnormal. That would absolutely be something that we'd want to have an alert. And AI is great at baselining what those normal activities are in an environment as well. All right. So, so if we're doing log analysis, what are the primary logs that we need to look at? Overall, for Active Directory, Logon Tracer from JP Cert uses these: the 6424, the 6425 for logon and log off failure, Kerberos authentication for 4768, Kerberos ticket request, which would be 4769, and then NTLM authentication and special privileges. You can do a lot with just those logs. Now, there are going to be blind spots, but we're trying to hewn and make sure that we're getting what we need to start as well. So let's say that this happens. You have somebody that's trying to log in and they have this one system that is logging into 232 separate accounts, right? That's 240 total login failures. That should create concern. That should absolutely create a concern. And then we can start doing some investigation on the actual event logs. What is the source workstation? What accounts are they logging into? And that brings us to our next lab. So for this next lab, it's going to be enterprise log analysis. And this is going to take us up to and through the break. So we'll resume at 10 after. So we can set the timer team for 30 minutes. So we got 20 on the lab, 10 for the break. So we're going to do domain log review. So you're going to first use Deep Blue CLI to do analysis on these logs. You're going to start there, right? And you're going to run it against these enterprise logs. Now, if you have time, you can do 0 to hero, Black Hills. We have a webcast where you can see what was the attack that generated these logs. You can actually see it live. We did the entire thing live, step by step, by Kent and Jordan. So you can see what it looks like. And you're going to see it detects lots of password authentication failures, right? We got 240. Then you're going to open up the event logs associated with that particular attack. And you're going to open it up in Event Viewer. Double click. By the way, if this lab doesn't work, it's because you clicked one of 2 things. Either A, you clicked on the wrong logs, or B, you didn't scroll down in Event Viewer. So let me show you that first one. You need to open DC2 SecLog domain password spray. Notice that there's DC DC2 app log. That's not the right one. There's DC1 domain password spray. That's not the right one. There's DC1 app log domain password spray. That's not the right one either. Going to go to DC2 seclogs domain password spray. Then when you open it, odds are it's not even going to open it to the right place in Event Viewer. You're going to have to scroll down to saved logs and open those right down there after it's been opened. Then you're going to sort on the event ID number, and you're going to go down to the 4776, which gives us a little bit more information. And then you see all of the names of all the failed login attempts of that attack. And like I said, if you have time, go check the YouTube video that I just shared as well. So we're going to set the timer for 30 minutes. Let's start the clock. We got 20 minutes on the lab and 10 minutes for break. And I don't know how they time it. It's one of those things. I hope that stays a mystery whenever Ryan sets these things up, and then the music ends perfectly. All right, so let's go ahead and let's do the enterprise log analysis, and then we're going right into another lab. This one's kind of cool though, because it is a brand new lab. I'm going to share a code with you all. If you could do me a favor, this is the code that you can put into MetaCTF to unlock the new Rita VM. This is a new VM for a new class that I'm creating for some packet level analysis and some log level analysis and threat hunting. So if you guys could try to use that code and let me know if that code actually works. You would go into MetaCTF and you would go back to labs list, and then you would put that access code in here and then submit it. All right. And then it's going to open up the Rita V5 lab, which is a different lab. All right. So pretty cool. I'm excited about this. It's a new lab. It's going to be really, really neat. So just sit tight and we'll get to that lab right as soon as we get done with this one. All right. So I'm going to I'm going to open up PowerShell first, and I'm going to CD into the Intro Labs Deep Blue CLI master directory, which is where everything exists. And then we're going to run the Deep Blue CLI against the password spray. And with this, we're going to see that there's a large number of failed login attempts, right? Like we can see that there's 240 failed login attempts. And this is kind of what like UEBA does. It's going to go through and it's going to identify that there's some kind of pattern within the logs, right? And if you're looking at this 240 failed login attempts, that's actually at least 240 different logs, right? So it's not just one log telling the story, it's them working together. So now what we need to do is we need to go into Explorer, File Explorer. We're going to go into Intro Labs, Deep Blue CLI Master, and we're going to go into the Ent Logs directory. And we're going to open up DC2, not DC2 App Log, not DC2 System Logs. We're going to go DC2 Sec Logs, Domain Password Spray, double click it. I'm just going to open up Event Viewer here in just a couple of seconds. And then we can select it. Once again, it totally didn't bring up the right event logs, which is pretty typical. You have to select down here in the saved logs. And then we do a just basically a sort on the event IDs. And we're looking for specifically the 4776, right? So 4776 is nice because it's going to tell us what is the user account and then what is the source workstation. So very clearly the source workstation is compromised, because if we're looking at this, we have this WinLab workstation 9 tried to log into the Timmy account. We're going to need another Timmy, right? And then we can look at it. We've got Roderick, Sir Roderick the Brave. Was it Roderick the Brave? Sir Roderick the Brave bravely ran away. Or was it Reddick? I can't remember. I think it was Sir Roderick. Not sure. Someone will correct me on Monty Python history because it's not that far. Samantha, you can see multiple failed login attempts. All Sir Robin, that's it. So you can see all of these failed user attempts, and we're seeing just this really tight time frame around them as well. And that's the important thing that we're actually looking for with that. All right, so now it's time to play with the new lab environment. All right, so if you are here, if everybody can get to this screen, this says SOC Core Skills with John Strand. right? So now if you go back to the lab list right here, if you ran that code, I'm gonna put that code back in the Rita, oops, it's not what we wanted. Let's put in the Rita code, right? There we go. And it should have added this Redify VLab, right? So you can view and manage the lab right there. And now it's the same thing. You just select start lab, and it's going to take a number of moments for it to actually start up and get running. All right, because the next lab that we're going to do, go back to the lab directory, is going to be the Hayabusa lab right here. And if you want, you played with the Rita AC Hunter, there's a whole new lab here on how to pull in logs and do analysis on those logs. So this is just another way of doing Rita analysis. And right now, that's just a wireframe for what the lab is going to look like here in a little bit. I have two new Rita labs. There's one. It'll show you how to import logs, and I'm going to build a new lab around it. So, and then we have these labs as well. Can jump over, and these are step-by-step threat hunts. So you'll be able to go in and list out the data sets, look at the beacons, and then you'll see the answers. We have a bunch of different questions for those as well, and you can do that. But the purpose of this particular lab at this point is Hayabusa. So when we're looking at Hayabusa, we just got done using the Deep Blue CLI to analyze event logs, looking for indications of a password spray attack. But that isn't the only tool that you have to actually look at event logs. We're going to be using Hayabusa, which can look at a number of event logs within a directory that has sysmon data, and it can search through and find potential attacks in the sysmon data. So you're going to become root, you're going to make a directory called logs, you're going to cd into logs, and then you're going to grab this EVTX attack sample. Then you're going to do Docker, you're going to run, and you're going to be pulling down Jim Klossing's Hayabusa. Jim is a friend of mine I haven't seen in years, way back in the days of the SANS Institute. He's pretty awesome. And you're going to log, and you're going to open in the data from the file sysmon EVTX. And then Hayabusa is going to analyze it. And then we're going to get metrics. What are the event ID metrics? Then we're going to get timeline data. And then you're going to look for any potential attacks where people are running command prompts, PowerShell, Who Am I, and Mimikatz. So it's yet another tool that gives you the capability to do that type of log analysis. And this is going to take you about 15 minutes. This doesn't take that long to do. Yeah, if Jesse, if you want to do this, go ahead and add the code to note taking for this class. That's perfectly fine. So let's go ahead and give this 20 minutes on the timer, and then we'll come back. I'll do the walkthrough. We'll set it up for Velociraptor. We have two more labs after this one. And if you have more time, you can jump into the Rita 2 Part 2 lab if you want. That's up to you. I don't have this one completely written yet. We're still working on some things for it. But that's it. So we got 20 minutes for the lab. Set the clock. I'll do the walkthrough. Then we'll come back, and then we'll hit Velociraptor and EDR. And then we'll close out the day with email log analysis. So get rolling. And we're back. Hey, everybody. All right, so let's go ahead and let's jump through this as well. I see that you guys are really digging the Hayabusa quotes that come out of it in Japanese. Like my Japanese is really bad now, but I do remember one thing and one thing only. It's that Nihongo totomo muzakashi desu ne. So let's go ahead and let's jump straight into it. So the first thing that we're going to do is, of course, become root on this. So we jump in, become root, make a directory called logs, because we're going to tie the log directory in our Docker container. I also like this lab because it is using Docker. Docker's not quite virtualization. It's kind of like quasi virtualization. So we're going to pull down our log samples. That didn't take long at all. And then we're going to run Docker. Once again, we're using Jim Klousing's Docker container. So Docker's going to go out. It's going to get the information. It's going to pull that container back down. Then once it gets it, it's going to set it up. And then it's going to mount the log data, the sysmon logs that we have right there. It's going to mount that and then do analysis within the Docker container and give us the results. Woo! Usually I can say that, and it's like I do it in the amount of time it takes for it to run But that's pretty powerful, right? We got the number of events. We got 565 events in the Sysmon EVTX. That's good. It's only about a meg, which is perfect for a lab. So let's start seeing what our event ID metrics are. Like, what are the events that we get from the Sysmon logs? And you can see that 90% of the logs are process creation logs, which is pretty cool for us, I think. We have some registry value changes, image load, file creation or overwrite, network connections, right? We have 3 network connections with event ID 3. We have registry object creation and deleting. So process terminated and process access. So that's cool. It's giving us a breakdown of what the logs actually look like. Then the final one is, let's take a look at that timeline, not second, that's the second to the final one. We're going to look at that timeline associated with when these things fire. And this is all the way back in 2019, but Sysmon hasn't changed and Hayabusa hasn't changed as well. And it's going to ask, what do we want to use for the rule set? So I'm going to use the core rule sets. You know what? I might play around with it on that, we'll just do all rules. What the hell? Include deprecated rules? Nah, we don't want deprecated. Unsupported rules? No, don't. Somebody was asking how often are they updated or customized? Fairly recently. Last time I ran this, they were updated within the month. I don't know if it's been updated that much since then, chat. So yes, they do update this, but this is kind of like an intrusion detection system for log analysis, which is cool. Noisy rules? No. Sysmon rules? Yes, because we are working with Sysmon. Now it's going to go through each one of those rules and it's going to go through each of the different event logs and it's going to look for any matches of any level of alerts that we have. So it's loading up all these rules and I may have shot myself in the foot on that because I pulled in the full set of rules. Oh my God. I'm gonna tell you, I talk about this before, but I talk in front of people and I have like no problems, but as soon as I have to sneeze, it's over. Like all of a sudden I get stage fright. It's the strangest thing ever, right? So with this, it comes and it says, okay, so emergency rules, critical rules, we have 11 that were fired. We have 48 of the high rules that fired, 110 medium and 24 lows, right? So if we're looking at these, the critical system is the Microsoft Edge Win 10. And the emergency alerts are, we got sticky key, like backdoor usage from the registry values, and then WannaCry ransomware. We have 4 of those. For high alerts, Proc X, Sysmon alert, dumping of sensitive Hive data via reg, and then suspicious paths, and then regserve32 execution from a highly suspicious location as well. So right there, we've got some really good information as to how just badly messed up this particular computer system actually is, which is bad. So now we can actually do some really cool stuff. We can do regular expression searches through the event logs, which I just think is a neat little add-on that a lot of people don't know. So instead of looking for the event logs and just focusing on what Hayabusa has built into it, you can actually do some regular expressions. So we can look for cmd.exe, we can look for PowerShell, Who Am I, and Mimikatz, see if we have any logs that match those strings, and sure enough, we do, right? So we have a lot of CMD executable runs, and you can see that a lot of it was executing from the atomic red team directory, which is pretty neat. All right. So that's another tool that you can play with. Now, I mentioned the extra read elapse, right? So I'm going to show you those really quick so you can see how that works. So I'm going to go to read it too. And it says you can do these first. So I'll do one of those first, just so you can see how Rita works. So we run Rita list. Rita's going to list out what data sets exist within this. Although, there we go. So we have a number of different data sets in here from TeamViewer to RDP, right? Now, if we want to look at any of those data sets, we just say Rita view, and then the new Rita does its magic, and we get the full curses-like display. of how this particular one works. And arrow keys work. We can get additional information about these different things as well. You can actually do some additional searches. So one of the cool things about this is it's showing you what are the modifiers. So if you can look at, these are two are critical, right? We have prevalence is low. That means there's not a lot of systems making the connection. We have a MIME type mismatch. Now, MIME is where you identify file types, and that means the data that it says that it is and the file it is not the same on that as well. So we can scroll down and you can see how we import the logs. And then if we want to close that session, which I do, I'm just going to go Control C. And that is in and of itself pretty cool, right? But I want to go back to this one and show you how we can import logs and do analysis. So I'm going to do make a directory ICMP logs. Then I'm going to CD into the ICMP logs. And then we're going to pull down the Zeek logs from the malware of the day. We're going to unzip those Zeek logs. All right. So if we can less out these, let's do con logs. I can show you what Zeek logs look like. This is what a con log looks like in Zeek. We have the actual connection strings. We have the amount of data, the amount of time. We have all these different attributes in that log. So what Rita does is it makes sense of what those logs actually are. So now I can import those logs and let Rita do its processing, put it into a new database, the ICMP Go shell. There we go. Rita's doing its analysis. Now, if I do read a list, there will be a new data set that is just created. That's the ICMP Go shell right here. And then I can view that data set. So really, the way that this lab is going to be progressing in this class is taking raw Zeek logs and doing analysis on the raw Zeek logs to get people comfortable with the idea of how you can use Rita as part of a network threat hunt. So that's where this is all headed. So we're getting there pretty quickly. All right, so we did Hayabusa. Let's talk a little bit about EDR, and then we're going to get to the Velociraptor lab. So what is EDR? EDR stands for endpoint detection and response, and that actually can mean a lot of things. They actually separate out things like EPP, like endpoint protection, which is where you have your standard virus signatures and virus definitions on that as well. Sometimes it's just black box flight recording. Sometimes it has the integration into an overall security orchestration, automation, and response. And then sometimes it could be tied together with network level detection and response. And then that's what we call that extended detection and response, which is where Palo Alto is spending a lot of their time, effort, and money trying to market that as well. And there's a lot of vendors in this space, a lot of vendors. Probably need to update this slide, but yeah, there's a lot. And it's kind of interesting to me because they really kind of do the same thing in just kind of different ways. It's very hard for me to say which one is better than the rest, right? So if we're looking at a lot of them that we are more afraid of, Microsoft is definitely way high up on that list. Like Microsoft Sentinel, EL3, P2 at least and higher. If you're running that through Sentinel, it's not easy to get by. It's really good. And that makes sense because if you're looking at what has happened with the EDR space, is your EDR is only as good as the amount of data that's being fed into the machine learning on the back end. So if you're like Legacy Cylance, if you're somebody like even Signet, and you're not a CrowdStrike or a Microsoft or even a SentinelOne, it's really hard to compete because the amount and log data volume that they're dealing with to train their models is just a fantastic amount of data, right? And that's ultimately what is going to win. Darktrace, not so much. Darktrace is kind of a weird thing. I don't talk about it all that much because they're a competitor for AC Hunter, but they're kind of not anymore, right? The Darktrace product is trying to pivot off of network detection and response, and they're trying to move into overall unifying AI. And I think that pivot is a bad call for them because they were okayish on the network detection and response side. They weren't great. but they were okay. They were probably way more expensive than they needed to be. Whenever they pivoted into kind of the EDR, SIM, AI realm, there's a lot of vendors that do things better. The other thing that's kind of weird about Darktrace is go look at the history of the founder. Some really weird stuff has happened. The founder died, I believe it was the founder, one of the executives, died in a ship that sunk in the Mediterranean. And apparently there was highly classified data on that ship, and like a bunch of nations cordoned off where that ship was so they get the classified data out of the safe. So it's really just wild if somebody can pull down the news articles associated with it. It's kind of a crazy story, right? But the problem with vendors is they kind of tend to lie, right? Like we do a lot of vendor sort of like dog and pony shows for like AC Hunter, where we talk to people. And it's kind of hard because we're talking about what our product does. We talk about how we're elevating it with BHIS and the pen testing side. And then we have people who are like, well, does your product have a zero false positive guarantee? And I'm like, what? Yeah, one of the other vendors says there's zero false positives in their product, none whatsoever. And I'm like, well, they're lying. I mean, clearly they're lying. And like, what, they seemed really confident that they had zero false positives. And I'm like, well, honestly, I am, running an offensive company. We do 700 offensive engagements a year. My team doesn't look at some of the vendors and go, oh, well, we got to give up. We can't bypass to them. It doesn't work that way. So anything you hear with vendors, you have to take with a grain of salt. So why is EDR so incredibly important? Because if you don't have incident response, it's an absolute nightmare without it, right? Trying to get answers from multiple computer systems is very, very difficult. And correlating attack data across multiple different endpoints can be very, very hard as well. And then going back to Windows event logs, they're just hot garbage, folks. They're just really, really bad event logs. And not except for Sysmon, you cool. But trying to pull all that stuff together is tough. So what a lot of people do is they rely on their EDR vendor, right? Like we use Lima Charlie in our SOC, mainly because like Whitney and Eric are like they're doing some consulting with us and helping us set it up, and they're like really good at Lima Charlie and like training the team up and getting us set up. But that's awesome to have that type of power. There are free and open source products out there, just as a heads up. Now, I'm not a super fan of anybody that doesn't have a free or open source option, right? If you're looking at Elastic and you're looking at Lima Charlie, you can set up with like a 30, 60, or 90-day trial from them where you can actually use the tool. And it doesn't require some elaborate sort of, like weird kabuki dance to get it set up in your environment and get running. You can just run it. In fact, we have some labs where you can set up and you can run Lima Charlie. And if you want me to, let me know in chat if you're interested and I can pull those down for you. What the hell? You're all going to say yes anyway. So let's go ahead and see if I can go to my labs, go to Strand.js. Go course navigation. So this is kind of the outline of the new SOC lab. We're setting up some stuff. So if you want to keep going, you absolutely can. But we have Lima Charlie hands-on right here, and we have a Lima Charlie lab and an Elastic Cloud lab. There we go. Now, we usually don't run this in my class because having 100 people log into both of these platforms makes these platforms go, and then fall over. So I just shared both of those labs in there and you can see those. But this is all through setting up the cloud version, how to set up Lima Charlie, how to set up Elastic. This one's Elastic, this one's Lima Charlie. So you can go through, create an account, set up with an email, and then learn these. Now, one of the cool things about these particular labs, and I recommend that you do it on your own time, is because if you're trying to get a job in this industry, if you've not used a commercial product, it's actually fairly difficult to get a job in some situations. So we wanted to create a couple of labs where you can play with Lima Charlie and you can play with Elastic so that you can put it on your resume and you can say, yep, I totally have experience using Lima Charlie and using Elastic as well. So All right, so we're going to talk about a number of tools like Waza, and you should always refer to it as Waza. Anytime you meet the vendors, you should call it Waza. And it's really cool. One of the coolest things about it is free. They do have a paid support subscription service on it as well, which is neat. Feeds data into an elk stack like most things do, and it's one of the most talked about tools in this class. We don't use it in this class because it's not lightweight. It requires a pretty big setup to get the Elastic instance up and running properly. And that's one of the reasons why we love Velociraptor. Velociraptor is the one that we use in my classes because it is very, very quick to set up. It is an incredibly lightweight install. The server and the client is incredibly small. Good pedigree, right? The Velociraptor people were the people of the Rapid 7. And before that, they did Recall at Google and Google Rapid Response. So Velociraptor is part of that continuation as well. So once again, when we're looking at logs or we're looking at EDR, once again, false positives are not a thing. They're detection tuning opportunities. You can look at things like service accounts, help desk, systems administrators. Tuning is our job. And whether you're working with something like Lima Charlie, Elastic, whatever tool you're using, you got to learn how to tune the actual rule sets as well. Before we get into the lab, I want to share my panicking alerting levels. So if we have a single repeating alert, I'm interested, right? Like it's going to be something that needs to be cleaned up. It's going to be a thing. But if I have multiple different alerts on a system, right? Like not just one alert that just pops up, but I now have multiple different alerts on that system, I'm now getting really interested. And then if those alerts move into network connection alerts, now I'm getting really, really excited. And if that's happening on multiple systems, it's time to call the customer and say, shut the internet down because everything is on fire at that point. All right. So all of this kind of starts tying together. You got AV and EDR, network security monitoring, user entity behavioral analytics, and SIM. And if that all is configured correctly, it's all tied into protection on the endpoint. So we got Ricardo is asking about AWS, right? And the mess. Yeah, we'd probably be like head exploding in scanners with the AWS thing. So on the AWS thing, I don't know if you guys saw some of the rumors. I talked about this at the beginning. Did anybody find any confirmation on that? Because so far I've seen one article that AWS let go of like 40% of their engineers a few weeks before everything went down in flames because they were handing things over to AI. But I would like to see some confirmation on that as well. All right, so that takes us up to the next lab. Now, this is not in the hold on. This is not in the Rita one. And I'm going to just stop the Rita cyber range right now because I don't need it. So I'm going to destroy Rita, keep the Windows one running. I'm going to close some of this stuff out. Just feel like I need to declutter my life a little bit. There we go. There we go. All right. Go to navigation and I'm going to throw a Velociraptor in the chat. There we go. I'm going to throw a Velociraptor over here for you all. There we go. And this is the lab we're going to do. Now, once again, this is going to be a lab that's like 20 minutes and then 10-minute on it. And then we're literally just going to have a few slides where I'm going to talk about email. And then I'm going to leave you with the last lab, which is the email analysis lab. And that particular one, we're just going to ride out class and ask me anything on that one. But basically, you just throw it into Sublime and then it's awesome. Sublime does all kinds of cool analysis on it. So let's go ahead. So Velociraptor, they have some training. You should check it out. You're going to CD into intro labs. You're going to fire up Velociraptor. Now, most of this lab is the defaults. You can read them and just kind of go with the default answers that you have there. However, right here, do me a favor, whenever you're running a GUI user and it asks for a password, a number of students are like, you know what, I'm going to make it the easiest password in the world. No password. Please give it a password, number one. Number two, give it a password that you will remember. That's really key. A password that you will remember. Because I have a lot of students that come up with a super strong password and nothing. They get nothing because they forgot what their super awesome password is. Don't forget that password. So we're going to log in, or sorry, we're going to fire up Velociraptor. We're going to set up the server config. We're going to start the server and connect to it. Then we're going to log in. Now, at this point, we have the server is running. Now we need to have a client. We're going to open another command prompt, cd into intro labs. We're going to run the MSI, and then we're going to run the client. Keep those terminals open. Go back to your Velociraptor server, click the little home button. You're going to see the number of connections go up. Click the little drop down, show all. It's going to give you a randomly generated client ID with your system name present there. And then we're going to run a shell command against that computer as well. Then we're going to execute it, get the results back. That's cool. We can run individual commands. But one of the coolest things about Velociraptor is you can run commands and collect data on multiple systems in one shot. So to do that, you would do target, and then you're going to add a hunt. You're going to name it something, whatever you want it to be. You're going to select the artifacts. And I usually just do PS tree, just so I can see the process tree associated with that. And then you're going to go through, hit review, and then launch, and then push the play button to get it to fire off. Takes a few moments to get the results back, and then you're going to be able to download the CSV and then open the summary and then see this PS tree results. So like I said, we've got 10 minutes. Actually, this one's pretty quick. Let's do like 15. So set it for 35, folks. There we are. Sorry, 25. And then we'll resume. Let's kick it off, everybody. We'll see you on the other side where I do the walkthrough. It really is bad when I start talking and I haven't come off of AV mute. Just sit down and just start going. Not good. Not good at all. All right, so let's go ahead and let's go through this lab. And then we're going to talk a little bit about email. And I'm going to kind of leave you to your own devices for the email analysis lab, which is actually pretty easy to do when working through it. So, and then we'll move into the Ask Me Anything. And I think Zach's going to join us as well for Ask Me Anything. I know he's got stuff going on today, but he might be here too. All right, so we're going to generate the config. Now, this is one of the things I love about Velociraptor, once again, is it's just so lightweight in what you're doing with it. Come on, go Velociraptor. There we are. We have the OS will be a Windows operating system. We're going to store the logs into the Windows temp directory as well. And we're going to do a self-signed SSL certificate, which is why we get the errors. It's just going to be listening on localhost and port 8000. And the GUI is going to be on 889 as well. And we're not going to do anything with WebSockets. We're keeping the vast majority of these are the defaults as well. We're not going to do anything experimental. We're not going to use dynamic DNS. And I'm going to leave it empty there. Generates the config that we just created. Takes a couple of seconds. There we go. Now it's asking us where we're going to put the logs. We're going to put the logs in Windows temp. And then once again, we're not going to do the experimental one with a shared server. Might actually do that later on. Never mind. Where you want the configure the file to get dropped, it's going to get dropped into serverconfig.yaml. And for those of you that don't know, YAML is yet another markup language, just another kind of XML format for sharing information. Client config, it's going to automatically generate the client config, and we're done, right? So we have just generated the client configuration and the server configuration in like 2 minutes. Pretty quick, right? Now, when you're doing a deployment, though, you would want to push that client config to all of the systems that you're investigating. And then we'll show you the startup on how you would run the startup. And it basically is you're using that client config. And what you usually do is push this out with group policy and then have that configuration stored on a shared server location so everyone can run it. All right, now we're going to create an administrator user. So we're giving him the name of root. It's going to ask me for the password. I'm going to put in Tor because I'm feeling exceptionally nostalgic today. So we're going to go ahead and run that Tor user. And then we're going to execute the MSI. Now, The Microsoft installer script is going to create the registry key values. It's going to move all the files to the appropriate location, basically just now prepping the system for Velociraptor to execute. And then we're going to start the server. Be verbose. I like to see what it's doing. Looking green. Looking green. There we go. Now we can connect by going to port 8889. So we'll go ahead and open up Microsoft Edge. I haven't seen any news today. Let's see what Microsoft Edge opens up, like fresh horrors, and go through. And there we go. We're going to paste this in. Not private. Once again, it's a self-signed certificate. We're expecting that. My user ID is root and my password is Tor. I think I should switch my password to Toot. So, you got like the root Toot password. I don't know. Seems weird. All right. So we've got that up and running. We're now connected into the server and now we're ready to open up another command prompt. So go ahead and open another command prompt. You can do that here. Right click, run it as administrator. It's pretty key. And then we're going to cd into intro labs into that directory. And then we're going to fire up the MSI. Once again, the MSI puts all the different values in the registry, all the executables in the appropriate directory, so that when Velociraptor runs, we're ready to go. And then you remember that client config that we created just a second ago. Now we're using it, okay? So we're running Velociraptor. We're saying the config is the client config, and we're just going to run it client mode and verbose. Now, with this, I'm running it in such a way that it's not installing it as a service that just goes through and just runs it, right? I want to see what it's doing. For the purposes of this class, it's really important for me to see what it's doing when that client is making the connection back up to the server. So you can see how the client's running here, and you can see how the server is responding, right? It's receiving a post of a length of, 12, 19 bytes from this client ID, which we're going to see that client ID, but you can see how that client is now communicating with the server. All right. Now, once we're here, we can click this button and do show all. And now we're going to see our client ID pop up here in just a second. Although my server is now froze. This freeze for you guys? My system's running a little dodgy. It was fine for you. Isn't that nice to see it like blow up in the face of the instructor? We can see it trying to do stuff. So it is doing something. It's just really slow. But you can see where that client ID is connected in. My client ID is D726F5, whatever, ends in E5F7. All right. Well, I kind of need that to show all. Let me kill this and start it over again. I do not want to go there. Let's go to 127. I do not want to do that. There we go. Oh, that's bad. That's no good. Am I going to the wrong IP? No, no. I think I went to the right place. You know what they say? Sometimes you just got to back up and run over dinner twice. All right, so I'm going to kill it. There we go. And I am going to restart everything. There we go. Root and Tor. Here we go. Go home. Drop down, show all. Turns out turning it on and off again, off and on again, Once again, saved the day, right? Worked. All right. So now I can see I have that client, which matches the E5 F7 that we saw in the logs being generated in the background. So at this point, I now have access to that client. I can choose to run a shell command, like I can run CMD and I can do task list. Let's do /M, and then I can launch that against my system. Takes a couple of seconds. You can see it doing stuff over here. And then I can click the little I, and then I can see the results. So almost anything that you can think of when you're doing a hunt on an individual system, as far as running individual commands against computer systems, you can see that result as well. Like anything we did for our regular Windows command line hunting, we can do that here as well. But now, if you wanted to run this hunt against multiple computer systems, how would you do that? If you're going back home and we look at our systems here, we can set up a number of tags on these systems. So you can drill into the systems and you can add client metadata and tags. And then it also identifies what the operating system is, which is also a type of tagging. So you can see here the operating system is Windows. I can create a rule with a hunt that goes and runs the command on every single Windows computer system in this area. So I can choose the hunt. I'm going to add it. I'm going to call it class like that. And I can say I can match by label or by operating system, and I can choose the operating system. I'm going to set that back to run everywhere. I can also set an exclusion condition as well. So pretty cool, right? So that allows you, once you've gotten Velociraptor installed on a critical mass of computers, you can execute this on that critical mass. So I'm going to go ahead and do, see if I can find PS tree. We're going to do this one because I want to see a process listing on it. And then we're going to select the artifacts. We got the, select the artifacts. We got PS tree. And I'm not going to change the parameters. It's just generic PS tree and the resources, CPU utilization. So you can kind of be nice and gentle to the environment as well. Here's the script it's going to execute. Then I select launch. Now, once it's here, I can select it, click the run button, and now it's going to run it against the system. And once again, you can see stuff happening over here, right? You can see the server and the client getting that data back and forth where it's executing PS tree, pulling all that process information, and then feeding it up to the server. Now, I can set that and do a full download. And here in a couple of moments, you're going to see this jump up. There we go. And it's going to show us that we have data. Uncompressed is 228K. I select to download, open the file, and then I have the raw results of that PS tree. Now, it provides it in two different ways. One is a CSV, your standard comma delimited file, and the other one is JSON, both of which can be imported into an Excel spreadsheet, and they can also be imported into like a backend database. I know one of our threat hunters, by the way, thrunting is not a word, and a thrunter is not a threat hunter. That's not going to be a thing that we're going to do. But we have threat hunters at Black Hills Information Security that like using large-scale Amazon database clusters to receive all of this data and then allows you to parse it. And one of the coolest things about this is you can see each of the client IDs is being recorded for each one of the actual results. And at the top, should give you a breakdown. We got the process ID, the parent process ID, username, command line, start time, call channel, and then the client ID tells you which system is running this, and then also what is the fully qualified domain name for that host name, which you can see here and here and here. So once again, you can open that up and get it into a database. So that's pretty cool, right? All right, so now I just want to spend a few moments and I want to talk about email analysis, and then I'll walk through the email lab that you guys can do. But I want to get into Ask Me Anything as well. So whenever we're looking at email attacks, we have spoofing fake from addresses in the display name, right? Display name shows a CEO, but the actual address is ceo@evil.com, right? Domains with lookalike, Microsoft support.net, and really trying to look for those different, like, I guess they're just dead giveaways that something is going on, right, with these emails. Mismatched split suspicious URLs. Hover, desktop, long press, mobile to look at the true target. I gotta be honest, the long press thing on mobile has always made me uncomfortable, right? Like, it's just like, you know, you're just like, to make sure that it's a landmine, push down on it. Like it just seems like you're flirting with disaster, which, by the way, horrible 80s movie. If you want to look at it, I think, God, who was all in that? I think Chevy Chase was in it. Demi Moore was in it. Was that Nothing But Trouble? I can't remember. Bad movie, just horrible. URL shorteners used without context, IP-based links, subtle typos as far as, like, simple misspellings and how they actually show up. Unusual attachments. So it's kind of funny with the unusual attachments. Is like, well, scripts and executables haven't been allowed in a long time. True, but attackers keep coming up with crazy ass ways to get it to a target. Like, for a couple of years, we would send, like, full on, there it is, Nothing But Trouble. We would send malicious stuff in an encrypted email, and a lot of the email services didn't have the ability to peer inside of an encrypted email. So you could put in attachments that otherwise would never make it through. A lot of this also isn't hosted within the email itself. It's actually hosted on a link where the user has to download it. And Microsoft has been doing really good with safe links, even though there are some bypass techniques and things like that as well. Business email compromise, a social engineering scam where attackers impersonate executives or partners to request high dollar wire transfers, right? Plain text email with no malicious link or attachment, high level urgency, and familiarity. Once again, out of band verification. I receive phone calls, like, a lot whenever I make a request from people, and they're verifying that I'm the one that made the request. And almost any of my emails where I make those requests, I tell people, please do me a favor, call to confirm that this is in fact me. Spear phishing, highly targeted individuals or departments. Whale phishing is just where you're going after, like, C-suite levels, right? Corporation of personal or corporate data tied in, and use of legal or official language inside of the letterhead. We're looking for what is the unusual sender and request for confidential reports or accounts. Attachment-based malware delivery, PDFs, embedded JavaScript, Word, and Excel with malicious macro. Even though Mark of the Web has really helped with that quite a bit, even though there are some tricks for kind of getting around that as well, using things like compressed archives that have droppers in it as well. Sandbox detonate all attachments, which most of your cloud-based emails do as well. Unusual. Oh, we went backwards on that. There we go. Secure email gateways, first line of defense, reputation based filtering based on sender URLs, sandboxing those attachments, and then rewriting. And you're looking at, like, Mimecast, Cisco email. We use Sublime. Once again, if you guys can go online, Sublime has this really cool text box that is just really cool on it as well. Somebody asked about Mark of the Web. So Mark of the Web is basically anytime you download something from the web, let's say it has a macro, it's automatically disabled. You have to go in and manually enable macros to get them to fire properly. And that's not easy for a standard user to do. So that's what they're actually doing. And it isn't Sublime Text, it's Sublime Email Security. Sublime Email Security is another vendor that does this stuff. So authentication protocols, this is just a really good thing. I almost recommend printing it out. If we're talking about SPF, DKIM, and DMARC, this tells you what the purpose of those are. So authorizing sending IP address, DNS record limits permitted email servers. So we're making sure if we're getting email from a specific provider, we can look and verify that that email is coming from the appropriate IP address. DKIM, looking at the integrity, right? We sign our headers and we verify DNS public key. And DMARC is the receiver applies a policy as FPF and DKIM failures and then sends reports. Like, when you're looking at organizations, these three things should be set. These things should be set to make sure that things are as secure as they possibly can. And here's the overall flow of how that sender receiver SPF check, DKIM verification, and DMARC evaluation works as well. All right, so the lab that you're going to do on your own is pretty cool. Let me go back to my lab directory, and it's email analysis. Just give it a moment. This says this contains a real phishing link. This actually got me completely locked out of everything at BHIS. Absolutely everything locked me down. So I just kind of want to show you Sublime first. So we have this email right here. And it says, I want you to open and inspect the email header. You can use a text editor, the from, return path, reply to, authentication results. Does it have SPF, DKIM, and DMARC? Is the domain legitimate? Does it display? Does it match the results? Is this a spoofing attempt as well? And we give you this really cool tool, right? So I can build an email file, right? And I can upload it to Sublime Analyzer, right? And this freaks out like right off the bat. It's like attack score. This is malicious. Suspicious HTML attachment, potential JavaScript with obfuscation. And then we can see what it's doing, smuggling with unescaped, benefits enrollment impersonation, request for purchase, credential phishing, and mismatch sender and return path. And it kind of answers a lot of these questions. So this is analyzer.sublime security. I can get you all to go to that link and give it a shot. It's really cool. Sublime is one of the vendors that we use in our SOC as well. So check it out. All right. So I think we're ready for the Ask Me Anything at this particular point. Pull this over. I don't know if Zach's still here. I know Zach's busy today. He might not be present.
Hello.
Oh, here he is. He showed up. Awesome. Very good. All right, folks, it's time to ask us anything. What questions do you have for us? Unfortunately, it's 10 minutes. I had to push a little bit. Usually the last 25, 30 minutes, I would push into tomorrow, but Zach's covering for me because I'm going down to Salt Lake City. And Zach, I think we only have like 3 labs for you guys on
Sweet.
tomorrow. I think we have the Wireshark lab, TCP dump lab, and I think the ASN lab, the 3 labs that you all be doing. So it's pretty cool. All right.
Thank you. And thank you for sending me the file, Jesse. Appreciate that. Yeah, I'll definitely do my best tomorrow.
Did
That'll
did
be
she
fun.
send you the email file? What file did she send you? I'm a little concerned.
Oh, she sent me the lab listing file. It's a PDF.
Oh, awesome. She's awesome.
All right, Jesse's fantastic.
So the question was, is it possible for us to do all the labs in the SOC analyst lab and our Meta CTF? The vast majority of them, absolutely, are going to be in the new environments. A bunch of them are outside, like we talked about Lima Charlie and Elastic. Those would be outside of that environment as well. So, and honestly, all this stuff you guys should be doing. Like you need to get this stuff. Don't just do it during class. You should be looking at it in terms of how do I get good at this? How do I make this super effective where it's second nature for me? So, all right, can we share Discord out, Kevin? What's the best way to harden Velociraptor client to prevent process kill instead of a breach? Yeah, so about that, it turns out that the attackers are starting to use a lot of these what we call RMM tools, and they are using them maliciously. It's kind of this really lame thing, but it is where we're starting to see people head right now. So just be careful about how you're executing it and where you're executing it from as well.
Corded War Cell, you can access the labs as long as you have credits. That is correct.
And even if you run out of credits, you can buy more and they're cheap, which reminds me, Zach, that's a good point. How about we go kill our labs to save those precious, precious credits, right? So I'm going
Good
to go
idea.
back to my lab list. Okay, I've got to log in. And then I'm going to kill my labs because I burn more lab credits than literally anyone else on the planet.
You're their best customer.
I am their best customer. All right, what else do we got, Zach? Well,
It does look like there's a question in Zoom. Is it okay to upload organizational emails on Sublime Analyzer? It
Yep.
will not compromise confidentiality for the organization.
I have never had a problem with that, and we know the people at Sublime. They're actually friends of Black Hills Information Security. But once again, I would always validate your corporate policy and verify with your security team if that's okay for doing cloud level analysis.
Uh,
Has BHIS ever seen EDR freeze tools or EDR silencers? Yes. We have a team of 5 people that do just that thing. So that's another webcast for another time.
Perry's asking, when investigating a suspicious device, what memory dump tool and forensic imager would you recommend?
WinPMEM is really good, and then also FTK Imager. So let me show you. WinPMEM is kind of hard to find. FTK Imager, whoa, I'm not going to go to those websites. But FTK Imager is a tool that allows you to do images of memory. So that's the one that I would probably use more than WinPMEM. I don't even know. I know it works.
Have you seen
Some
the
really.
LOL?
Oh, okay.
Um,
It turns out Velociraptor has it. So I would download it from the Velociraptor location for that. So WinPMEM and um, FTK Imager. But once again, dude, look at this. Like, look at these guys right here. Like, I don't know what Xtero is. Is that the new Access Data Company? I think it probably is. Those aren't ads, but at any rate. So those are the two that I use. But even more than those, just snapshot your virtual machines. Like when you're doing analysis on a server, almost all of your servers are running on some type of virtualization or cloud platform. Just be sure to use that.
did you see the LOLRMM.io? Did you see that link there?
No, I didn't.
Andy was telling us to give us a shout out to them.
Okay.
Looks like a bunch of curated
What
list of RMM tools.
what tools should we be worried about when uploading customer information for any SOC analysis?
So the next part of that question, I think, is the more interesting one about skipping Chat GPT. So how we're using Chat GPT is it's built into Copilot. So if you're looking at the controls around, like I don't feel super comfortable just dropping it into an LLM online. But if you're looking at Copilot, I'm paying for a license, there's access control, and Microsoft says that that data and what we do is specifically and only exclusively used by BHIS employees. So we have that control. So it's within the ecosystem of Black Hills Infosec and our Copilot environment. Now, do I believe that 110%? No. Hell no. Like, do you really believe that Microsoft is like honest? Oh, your data is just safe with us and we aren't sharing it and analyzing it in the background. They're liars, right? We know that they're liars. But when we're looking at this, what the hell are you going to do, right? Like somebody doing a basic Google search is that's going to dump it right into Gemini, right? So it's tough, right? But I am at the point where I'm basically saying, this is the world that is in existence now. So we are building our own LLMs in BHIS. We're creating our own models and things like that, and it's expensive. Just leave it at that, so we can keep those things internally. But it's really cool because we have one model that has no safety net at all. Like you're like, I want you to create an entire offensive campaign with all of the source code and bypass AV, and it's just like, here you go. It's like, holy crap. There's a lot of safety protections in place out there. So I recommend doing it within a corporate account that you're paying for. The free stuff is absolutely going to go out the back end. Also, I want to talk about the narrative, right? So Microsoft swears up and down that they aren't going to take our data and leak it and use it to sell stuff, right? If that's not true, that's not on me, right? That's on Microsoft, right? But if you're doing an engagement and you're doing stuff in free versions, which make it abundantly clear that you have no right to privacy for anything that you're doing with the free stuff, that's on you. So always look at the narrative. Like, how is it that we can be blamed for this? And what is our protection and liability as far as moving that blame to another entity? What other questions do we have out there?
How would you compare Proofpoint and Sublime email security?
I like Sublime better. I'm sorry. I just do. And that's from an offensive perspective. And that's like my opinion, man. But when we were looking at vendors to partner with, we talked with our testers, we talked with our team to figure out which one was probably the more terrifying one. And Sublime was the one that was more up and coming for us to be able to work with it. No real direct opinions on Cisco email security. So, and here's what you can do, test it. Like, don't trust me. Start sending through malicious emails and see how they get through, if they get through. We already do. Okay.
Yeah.
I have opinions based on one of those words and they aren't great. You know what? Here, look, we can rip on Cisco all day long. Like I'm here for that. But the fact is, Cisco literally saved the internet. It totally did. If you go back a number of years ago, when did the Pix come out? Uh, do you remember, Zach? Like when did the
No,
Pix hit?
no.
So the
Yes.
so Cisco, the entire internet was in a tremendous big problem, and it had to do with the limitation of IPv4 addresses and how that was going to work. And the Cisco Pix was basically the product that really brought network address translation, port address translation to the forefront and allowed the internet to continue to blossom and to continue to grow. So even though Cisco is like not one of my favorite companies, right? Because they're a huge, large company, and now they're not going to sponsor Wild West Hacking Fest. They did give us the Pix, and there's a great video out there on how Pix saved the internet, and it talks about the company that developed the technology for network address translation and what eventually became the Pix, which became the adaptive security appliance. So I like that stuff too. All right.
It was 2005.
2005, which doesn't seem that far ago, like that long ago at all.
It was 20 years ago. I thought
I
20
know,
years ago was like 1980. I'm
I know,
pretty
I know, I
sure
know.
it was.
There was a year, I can't remember what year it was, where somebody pointed out that Back to the Future, going back to the 50s, like they were closer to the 50s than they were to the current day. And I'm
Oh,
like,
Just
"What?"
gross.
Yeah.
why would you
I
do
actually, I gotta be honest, we get into this all the time. I dig getting old. Like
Well,
my
I mean,
expectations go getting old, like lower and lower and lower. They're like,
yeah.
dad showed up and he's awake. It's a win, you know?
Yeah.
I kind of dig that, right?
And he didn't spill any peas on the table.
Yeah. So good question. Most would now agree that SPF, DKIM, and DMARC are not reliable email security controls. Okay, but let's talk about what you're trying to do. You're trying to clean up the amount of garbage that's hitting your email gateway. Well, most organizations are using Google and Microsoft. That's not true on a global perspective. All right. If you're looking at that, it's very true in the United States, especially in large corporations. When you go globally, a lot of organizations are not using those cloud providers with those things in play. So what that does, that SPF, that DKIM, and that DMARC, is it actually reduces the signal to noise significantly. That would be the equivalent of saying firewalls don't matter because attackers know how to bypass them. Your firewall is still blocking the 99.9% of the garbage that's hitting your environment, and that provides value. And if you're looking at SPF, DKIM, and DMARC, same thing. It's blocking 99.9% of the garbage that hits your environment on that as well. All right. So another question was, how can you ensure when you're tuning a rule to exclude false positives to not accidentally exclude? So Lions, what you want to do is, honestly, what we're doing at BHIS is we start by creating an atomic from the atomic red team framework and from Red Canary, and then we can test that technique. And it should start that the rule fails, that technique fires and the actual detect does not work. When you run the technique, it should fire and detect whenever that technique works. This is just basic software engineering, right? Basic software engineering is start with a test case that fails and then build your code until the test case succeeds. All right. And that's it, everybody. All right, so let's get out of here. Thank you so much. You guys are going to have a great time with Zach. Once again, I'm sorry I can't be here tomorrow, but Zach has some cool stuff. He's going to go over the AST core certification, which is still in hidden beta. It's not out yet. And then we're going to do those labs and then do Ask Me Anything. and have a good time.
Gonna be a good time.
Yeah.
All right, everybody. Thank you so much.
All right.
See y'all
Have fun,
tomorrow.
John.
Everybody.
We'll miss you tomorrow.
Thanks. I miss you guys too.
All right. Bye. Have a good night, everyone. Ryan, go ahead and kill it with fire, or Kevin, whoever's killing with fire these days.